Understanding these risks early and, of course, managing them proactively is essential. The PV and BESS project life cycle graphs gathered
let's
from
say 2030, we see already we are hitting the 300,000 tons. So what happened in the end? I ask, what about the decommissioning? But the economics are completely different because the PV recycling is on its own.
Hello, everyone, and welcome to Sinovoltaics webinar. My name is Rasaya, and I'm a media manager at Sinovoltaics, and I will be moderating today's session. Today we'll be talking about PV and BESS project decommissioning, and the topic for long was ignored and seen as, well, we'll deal with it later when we get there, right? And happily, we've seen the growing attention to this topic over the past years. And according to Solar Power Europe recent study, by 2028, PV capacity in Europe should reach around 671 gigawatt. And when you think this is more than 1 billion solar panels to be decommissioned and recycled in the future, who will take care of decommissioning them? Who bears responsibility of this process in 30 years from now? How much will it cost? These are the questions we will try to find answers to in today's webinar. And before this topic, I will quickly share some practical tips on how to mitigate other major risks in different PV and BESS project lifecycle stages. So now, before I introduce our guest speaker, let me quickly share some housekeeping rules. So this webinar will last for about 1 hour, and 2 expert presentations will be followed by a Q&A session. On the right-hand side of your screen, you can see the chat box. Feel free to post your questions in the chat box during any time of at any time during the presentations, and I will address the questions to the respective speaker at the end of the webinar. This webinar is being recorded and will be uploaded on Sinovoltaics' YouTube channel. And if you want to stay ahead of the renewable energy curve, then don't forget to subscribe to our channel. So now I will invite Andreas Bach on the stage and will quickly present the speaker. Hi, Andreas. Good to have you.
Hello, Raza. Good to be here.
So Andreas is an operations leader with more than 25 years of international project experience. And over the past 15 years, he's been focused on utility scale PV and battery energy storage, working across the full spectrum of EPC, IPP, and owner's engineer roles. Andreas, you're also known for your deep expertise in execution quality, lifecycle governance, and CAPEX discipline, with a unique ability to connect design and construction decisions to long-term asset performance, operational risks, and even the financial realities of the commissioning and end-of-life planning. So good to have you, Andreas. And a couple of words about myself. So, in almost 10 years of my professional experience, I have worn many hats. Most of them were communication hats in various international companies, starting with the consumer electronics, medical devices, then insurance and renewable energy. Before joining Sinovoltaics, I worked at Estonian IPP. For almost 4 years, I lived in the heart of Europe, Brussels, where I was leading communication efforts for the second largest corporate insurance networks in the world. And now at Sinovoltaics, I look after PR efforts and run the company's renewable energy webinar program. So now, without further ado, let me introduce my topic. I'll talk about PV and BESS project lifecycle. What risks do we find there and how we can mitigate them, or at least some of them. Understanding these risks early and, of course, managing them proactively is essential if you want to deliver bankable, high-performing assets that operate safely and reliably over decades. So here I have the PV and BESS project life cycle graphs gathered from ResearchGate. But since the audience here is rather executives and decision makers, I will not focus on explaining these images in very detail. I would rather only focus on the three main phases in my presentation today. So it's the project phase, exploitation phase, meaning operational phase, and end-of-life phase. And then I will talk about the risks related to each phase and some mitigation strategies. The risks identified in the following slides I gathered analyzing various studies provided by DNV, PwC, TÜV Rheinland. So let's start with the planning phase. So in the planning phase, we have development, where of course we start, every project we start with a site selection. And of course, I don't mention that if you develop or if you plan a solar project, you should not build it in an area that is full of shade. That's, I think, a no-brainer to everybody in this virtual room. But of course, you should consider some extreme weather conditions in the selected site, and other environmental constraints, etc. Then another risk in this phase is grid constraints. We see that it could be a major bottleneck due to weak grid capacity or long interconnection queues. Then permitting and land lease risk. Of course, we all know that some communities may push back for the solar or BESS projects, maybe more for wind, but you need to take that into account when developing a project simply. And lastly, developers sometimes rely on overly optimistic yield assumptions. So underestimating losses or degradation might inflate energy projections, leading to unrealistic financial expectations and issues with lenders and investors down the line. Next, since we have secured the site, grid conditions, and we have the project in the paper, let's say, we are now good to go to start sourcing for equipment and contracting partners. So a key concern here becomes a supplier bankability. You are about to make a partner for the rest of 20, 30 years if we think about PV or BESS project. So you better choose a financially strong and stable supplier to avoid any warranty disputes or product failures or even manufacturing insolvency in the future. The next risk in the procurement phase is inconsistent quality, where we see that not necessarily components that you think will be used manufacturing your product are actually used during the manufacturing process. And then the last risk in the procurement phase, and I think that the major one, is poor contracts. We see this as the most common procurement pitfall: vague scopes, misaligned incentives, missing clear deadlines, and lack of clarity on responsibilities can jeopardize your project. As we go down the project line, we start the manufacturing. So different set of risks arise here. So we see that factory quality assurance issues, such as poor work organization or not the right attention to the testing or the product quality, can lead to bigger problems in the future when you install these poor quality assets in your project. Increasingly important is also traceability and ESG compliance. This risk is important and should be taken into account because it's no longer only a corporate responsibility for companies, but this is actually essential if you have your project backed by investors, especially institutional investors. You need to ensure that your supply chain is transparent. And finally, in the manufacturing, one risk and rather big one is delays. So you very often project developers have obligations to other stakeholders, and if delays arise in the project, if your manufactured goods cannot reach the site on time, you might also face some financial losses because of simply because of not being able to fulfill your obligations on time. As we now have the goods manufactured, we go to the construction phase, so where the design becomes reality. On the civil side, poor worker safety, low quality earthworks, drainage, and foundation issues can compromise the structural stability of your project and cause, let's say, long-term erosion problems. Then second risk in this phase is installation errors that could lead to outages, thermal events, or even underperformance. And the last risk in this phase is fire risks. Especially this is prominent for BESS installations, but not only. I think we all saw the headlines of fire breakouts in PV plants in Australia and US recently that were caused by poor electrical installation. Now we have commissioning and performance phase. Commissioning phase, sorry. So the commissioning is actually the bridge between construction and operation. So we see that a big risk is actually incomplete testing, because not all systems manufactured are actually properly tested at the manufacturing site. And this is because it requires additional work for the manufacturer, additional investment, etc. So different components, especially in BESS systems, might not necessarily be talking to each other, and you might only notice this issue when your system is already on site. Another critical vulnerability is control system misconfiguration. And here we're talking about incorrect inverter settings, weird SCADA logic, or poorly integrated BESS control that can significantly reduce system efficiency or even violate grid requirements. Finally, missing baseline data such as IV curves, thermography, or initial performance benchmarks makes it difficult to validate warranties or diagnose issues later in the asset's life. And very often manufacturers fail to provide these baseline data. Now we enter the operational phase, and the focus shifts towards maintaining your assets' performance over 20 and 30 years. So projects suffer when monitoring is inadequate, and poor monitoring leads to slow detection of performance drifts, failures, or safety issues. Then another risk we see is reactive maintenance, when problems are being addressed only when significant losses have already accumulated. And for BESS systems specifically, cycling abuse is also a major risk because operating batteries outside their intended depth of discharge or temperature or cycling limits can quickly degrade capacity, reduce lifetime, and even void warranties. And talking about warranties, the next phase is during the operation phase, we have a different risk, that is exclusions and gaps in warranties. This includes ambiguous degradation terms, unclear root cause requirements, or restrictive claim procedures. Then the next risk is regulatory obligations. So compliance risk from grid codes to fire safety updates can impose retrofit requirements or operational restrictions. And then traceability for claims is another important risk. Without accurate documentation, test records, and serial number tracking, owners may struggle to validate claims when components fail. And we reach the end of life phase of PV and BESS project lifecycle. So decommissioning is one of the risks that are not getting enough attention, and that's why we will delve deeper into this topic today, later in this webinar. But dismantling PV and BESS assets, handling hazardous materials, and restoring land can be costly if not budgeted early. Then we see the risk of recycling challenges, especially for modules and lithium-ion batteries due to limited infrastructure still and evolving regulations. And finally, risk of land lease restoration obligation, where landowners may require the site to be returned to its original condition. And of course, failure to plan for this can leave significant liabilities for you. So now, as I covered major risks in different PV and BESS project lifecycle stages, I would like to quickly share some mitigation strategies. What can you do to mitigate at least some of these risks that I just presented? Supplier selection is a service that we see more and more clients reach out to us. We check the background of the supplier, manufacturing and quality assurance procedures. We can visit the factories together with the client and provide independent evaluation of shortlisted manufacturers. As I mentioned at the beginning of my presentation, you are about to enter into a partnership for the next 20 years. So this helps you to make sure that the selected PV and BESS manufacturer is reputable, has strong quality and ESG standards in place, and is still in the market after 20 years. Then I mentioned weak contract and poor contract. Third-party auditor or Sinovoltaics can help you with contract optimization to avoid poor contracts and delays. When placing an order of millions, you better make sure that the contract actually works in your favor. Clear wording, clear responsibilities, strict deadlines and penalties if these deadlines are not met. Warranties, all these points can save you from major headache when the problems arise. And also inadequate testing measures. Adequate testing measures should be added in the contract to make sure that you get the highest quality of your product that you buy. Then the next thing is when the production already starts, quality issues might arise on the factory level, and to prevent these, Sinovoltaics team can help you with the production monitoring from the raw material delivery to the moment container full of PV modules is shipped to your site. We can monitor the process to avoid any quality issues. Then traceability and ESG. With this service can help you make sure that any raw materials used in your supply chain are sourced responsibly and transparently, and that no banned materials are used in your supply chain. And this is very important also when traceability for claims arise. Next thing is Selma and Essential. So Selma is our proprietary AI-driven electroluminescence testing solution that allows us to test 100% of your PV modules and rework them before they leave the factory. So even a small crack on the panel can significantly reduce module capacity and contribute to faster degradation. And standard tests done at the manufacturing site might only include sampling. So you don't necessarily get the full picture of quality of your PV modules. This same goes for BESS assets. We offer Essential service that can help you with the inconsistent quality and factory quality issues. And with Essential, a big amount of data is collected during these tests, which is then fed into Essential software for detailed analysis, where we evaluate each and every module and can push our analysis to the cell level. So allowing us to evaluate each battery pack, we identify volatility in individual cells, such as temperature shifts, voltage irregularities, capacity disbalances, and other factors predictive of earlier sign of battery pack and cells defects. Then the next service that can help you mitigate the risk of fire risks, incomplete testing, and missing baseline data is BESS FAT. So for BESS FAT, we do visual inspection, electrical testing, mechanical testing, performance testing, and safety testing. So it's very important that before leaving the factory, your BESS asset operates as it should. Every component talks to each other and operates well, and BESS allows us to do that. BESS FAT allows us to do that. Contract optimization, again, could help you avoid exclusions and gaps, so that in the contract you have clear indication of what exclusions is, that help you with warranties in the future. And the last thing is to address the traceability for claims. By conducting the traceability and ESG audit, you can identify and address potential environmental, social, and governance risks in your supply chain. So across the entire life cycle of a utility scale PV and BESS project, risks are interconnected, and mitigating them can start already at the planning phase. And in a multi-million project, these services that I just mentioned, these risk mitigation strategies, actually cost peanuts, but can save you from major headaches and financial losses, of course, in the future when the issues arise. And this is, like insurance, so premium costs minimum, but compared to financial losses if damages arise. So I thank you for your attention, and I now invite Andreas to talk more about decommissioning of PV and BESS projects. And I encourage you to share your questions in the chat box. So Andreas, over to you.
Thank you, Raza. This might maybe sound like a made-up story, but it happened to me many years ago. I was driving during the night on a road outside the city, forest, fields, left and right. And it was night, and suddenly a deer jumped in front of me on a road. And you know what happened? When a deer jumps on a road, seeing the headlights, it just freezes, paralyzes, and looking with his eyes into the headlights. I managed to brake, but it was a strange moment. And then suddenly the deer ran off. Why I'm telling you this? Because I had a similar déjà vu situation a few weeks ago in a board meeting. So it was about a PV plant, which was like planned through CAPEX, OPEX, design, everything was like done. And then we discussed about it. So what happened in the end, I asked, what about the decommissioning? Did we consider it as a line in the CAPEX or in a design? There was a dead silence in the room. Everyone with the same eyes like the deer. And yeah, it was a strange situation. And I was smiling and laughing and saying, sorry, guys. I didn't mean like to surprise you badly. I just wanted to know, if we have it modeled. And the answer was then in the end, no, we haven't, but why? It's 25 or 30 years in the future. Why consider now? And yeah, I don't know about you, but in all the years, in all the countries, all the companies, it was never in default into the planning. And I don't understand why. Because a project have a start, a project have an end. But the end is never considered. It's all about the CAPEX operations to have the LCOE as low as possible. But decommission is something abstract in a far future. So why is it so important, and about what scale we actually talking? So if you look at the European Union level, just today, we have around 90,000 tons of PV models to be recycled. We have today inside the European Union the capacity of 70 to 90,000 tons. But if you look now just 5 years into the future, let's say 2030, we see already we are hitting the 300,000 tons. And even further, if you look at 2050, we are at 2,300 kilotons already. So if you just stack the panels above each other, you're having a tower of 3,500 kilometers. If you consider or bring it into the context, the ISS is hovering at 400 kilometers above the Earth. So you can stack it 9 times in reaching the ISS. Or you can lay them behind each other and you can circle equator 4 times. So what is driving the growth is, like we're learning today, the degradation of PV panels are not that slow as we thought, so the degradation faster. And then actually this is also driving to a repowering boom. If you take the same size of panel today, compared to a panel like 10, 15, 20 years ago, it has 30 up to 40% more energy output just by the same size. And we're not talking about oversized panels. Also, like feed-in tariffs in few countries, they're coming soon to an end. And with the degraded models, it makes it very attractive business case to consider repowering, because nowadays we all talk about the bottleneck of the grid connection. So this plans with existing grid connection makes it very feasible to consider the repowering. So that all brings actually the panels into recycling. Not to consider like events like hail or whatsoever, which just forces you. And the European Union is already very strict on it. So there is the extended producer responsibility, the EPR, and further mandatory laws already in place, which make it mandatory for you to recycle. So you cannot just like dump it in a landfill like US is doing very often. You can also not export it for recycling because it is by law, you have to do it inside of the European Union. The only way to export a PV panel is actually for second life, but then every PV panel needs a certificate that the PV panel is operational. So from the investor perspective, what is mostly missing is actually the decommissioning in the models. The LCOE looks very clean. Everyone believes that the salvage or the recovered material will just cover the cost, but it does not, and later explain you why more in detail. And without the end-of-life plan, and some lenders already asking for this in your model, you're having like a risk exposure, which leads to higher interest rate when you're lending the money for the PV plant. And the end of life is not just only a plan or a tick in your ESG planning. It is a reality what you have to put into the CAPEX, OPEX, etc. So the whole market is already going into this. We have already, as I said earlier, recycling facilities in the European Union. So how to look at the cost? 50,000 euro per megawatt peak is the median case for dismantling a PV plant. That is excluding the salvage or the what you earn on the material which you're going to sell from the recycling. the return is between 8 and 12,000 euro per megawatt peak. So you can see in a cost of 50,000, there's still a bigger gap. The majority is actually driven by the dismantling of the plant, the logistics to transport away the material like the PV panels. And as further away the recycling plant is located, as more expensive it is. It is, for example, not feasible to have a project in France, let's say, and you want to send 1,000 kilometers to Poland because the recycling might be cheaper, but the logistics will just be too expensive to make it feasible. There are some consideration and calculations that in a radius of 300 to 500 kilometers, the recycling makes sense for the recycling plant. What could be a business case is actually mobile recycling plants, so that you send recycling plants to the PV plant. Otherwise, the logistics will just go up. So how to mitigate this whole risk? What you should look at is in long-term contracts, to have it already in an EPC or in an O&M contract, that you plan the recycling from the beginning. I mean, every PV plant have a warranty bond. You could also consider it as bringing in a decommissioning bond. For the recycling, you have to make sure that you have certified partners. You have to make sure they actually audited and carry everything you need to get your reporting in the end. Because you might be audited yourself, and then you need to prove that your PV plant have been recycled accordingly to the European law. So if we look at the design, there's already many things you could consider. I'll give you one example. I was recently involved where the ram and pull-out test was not successful. So of course the consideration was already, okay, let's put them into a concrete. We just drill and concreted it in. But if you consider then dismantling in 25 or 30 years, it is quite a hassle. So what we were doing is actually we talk to the special company for the static calculations who did the testing. We spoke to the supplier of the substructure. If we find different solutions, maybe a different kind of a pile or like a screw pile. And we went for a second and even for a third ram and pull-out test, just to make sure there's no other solutions than concrete. And actually we found a solution, and the project, the PV plant was constructed with ramming post only. Of course, we paid a little in front for the extra tests, but if you look at the total cost of ownership of the PV plant, the disassembly saved us some money, because if you're thinking about a 100 megawatt project and you think like 500 to 600 pounds per megawatt, you're ending up in thousands of cubic meters of concrete you're putting into the ground, which you have to take out. Some might say, Andreas, don't worry, we just repower, but repowering always goes that way, because some land plots have a hard stop going back to the farmer. So you're obliged to bring the land back how it was before, or the new panels in 30 years, they're not suitable for the substructure and the existing piles. There are also some more minor things. Many people or many companies doing this already for the stations. I mean, if you're looking at a plant today, which is 20 years old, most probably using concrete stations, but nowadays you plan rather with a containerized solution, which is CAPEX attractive. That is also attractive for the dismantling. Maybe what is underestimated is the as-built drawings together with the proper geographic information system, the GIS, QR codes, which you can place everywhere, and when you scan it, you will see the passport of what material is actually included. It makes it all easier in the future for the dismantling. So, long story short, you have already a lot of influence during the design phase to make the dismantling easier in a far future. So that are the costs and the consequences. Let's see how the market look like. So the infrastructure is already there, not at scale, but is there. Facilities are like everywhere now. You find in Germany, France, Poland, everywhere new facilities opening. There's also a proper process in place. The regulation and the policy by the European Union is already in place. So the market know exactly what needs to be done. If you're from the side of the recycler or if you're the side of the asset owner, is clear. So it creates actually a standard already for the feedstock or for the material flow, which will go into recycling. And if you look what being recycled, it's mainly glass from the PV panels. Glass can unfortunately not be used for PV panels again, but aluminum, silver, etc. Can be used, and it's already in the European Union. So that means also it is very attractive for production inside the European Union because you just gain the materials from recycling. So it will be interesting to see when we see the tipping point from used material from the mining or from the recycling. And also the finance and investment, it will be quite a standard that due diligence will check if you have the bonds in place, if you have the decommission in reserve in place, etc. How does it look like, the recycling? There's a good example, Solar Materials, a German company located in Magdeburg. They are going for the thermomechanical, and they're doing kind of reverse manufacturing. Is completely mechanical free, and the recovery rate is up to 98%. However, it is not yet sustainable on its own, so you can only recycle with a gate fee, and later I'll explain you what it means with the gate fee. The number one material which recycling is after is silver. We have like 1 gram of silver per panel. So that is the highest percentage in the revenue of the recycling. The cost per ton of PV panels to recycle, it's between 100 and 200 euro. It is really depend on the kind and size of the panel, but the median case is 150 euro. And if you look on the other side, the recovered material, it's in the median case only 110 euro. And that what I meant earlier with the gate fee, because there's a gap of 40 euro, which you need to pay when you're going to recycle the PV panels. So What are the lessons? So if you do not plan your decommissioning, you are having a risk exposure. Design with smart engineering can reduce the liabilities and the surprises in the future. And the policy is in place by the European Union, and recycle is actually not just end of the project. Recycling is actually, from the recycling perspective, the start of a new cycle. There will be a constant material flow as further you look into the future. BESS is a complete different story, because BESS, the life cycle, or when you're going to recycle, is only 8 to 12 years. That means if you run a PV plant, a hybrid plant, PV and BESS, during the whole lifetime of the PV, you have BESS probably 3 times recycled. So it creates a higher volume, and it also creates an early wave. So if you look at PV after 20 years plus, we're seeing the wave of recycling. The BESS wave is coming much earlier. But the economics are completely different, because the PV recycling is on its own. But BESS have actually shared facilities with the electric vehicle industry. So it goes to the same facilities. And also the BESS is not yet profitable, but it will be profitable in the future as soon as we have the scale achieved. And the European battery regulation is also really pushing to close this loop of new BESS and recycling. However, there is only so far a 90% rate of the recovered material. It will be all shredded, the lithium, nickel, cobalt, copper, to a black mass, how they call it. And that is like a secondary raw material, which is increasing in price. So circularity is not only a sustainable message, something where you have to tick. It is a capital protection. If you have that in your model, you already have a less risk exposure, and it makes you also easier if you, for example, sell a plant, or you're going to finance a plant and you're going through the due diligence. It is a bonus, an advantage, if you have already considered it in your planning. Thank you for your attention, and I'm happy to take your questions.
Thank you, Andreas. Thanks a lot for your presentation. I really like the closing remark of yours, that the circularity is capital protection. And yeah, everybody should think about decommissioning as definitely as a must thing to have in their financial model. We received quite a number of questions. Andreas, let me start taking them.
I have seen all the questions coming in, but I couldn't focus on it.
It's okay. It's okay. You were doing the presentation, so no need to look at them during the presentation. So let me start with a question from John. So John is asking, how important is site acceptance testing, SAT? Can post-shipment testing and post-installation testing mitigate further risk, in Sinovoltaics' opinion? So I'll take that one.
Mm-hmm.
many things can happen after the shipment has left the factory. So SAT helps you to see and measure whatever happened before your shipment arrived on site. So yes, SAT is a critical quality assurance stage, and it helps you validate the equipment performance on site, because what factory audits or pre-shipment checks can confirm, you don't know what happened during the delivery period. Yes. Another question we see from Ali. If manufacturers are looking at recyclable materials during manufacturing process, why are some products still difficult to recycle? Andreas, would you be able to take that one?
Yes, absolutely. There is like a rule, as more longevity you're making a product, as more hard is to recycle. And as more easy you make it to recycle, as less longevity it is. And I think with the PV panels, for example, with 25 to 30 years, we found like the middle ground, because now you can recycle up to 98% and you can do it already chemical free. But if you would now complain why we're not making it 50 years like last, then on the other end, recycling would become very difficult. And as said, if you make it very easy to recycle, the life of this product won't be that long.
Okay, thank you, Andreas. Then we have a question again from Ali. I guess it's dedicated to you, Andreas. What is the capacity of a mobile recycling plant on average? I think you mentioned that in your presentation.
I think we're not there yet. I have seen some concepts where they're putting like a recycling plant into a container, which you can then easy to transport to the site. But I cannot tell what is the real capacity. But we have to see in the future how this whole system develops and scale. At the moment, we're seeing rather like bigger halls with big machineries, and like the solar materials in Magdeburg, they're very advanced with roboter arms and doing all automated. So we have to see actually in the end how this will work out in a mobile plant.
Okay. Again, question for you, Andreas, coming from John. When conducting a decommissioning study, how do you predict prices for decommissioning in 20, 30 years' time?
Well, that is a hard question, because we can just take the market of today, the prices. And if we're looking at a typical PV plant, which was 20 years constructed, and with a recovered material, you have between 8,000 and 12,000 euro material income, what you sell actually. We don't know in 25, 30 years what will be the material price, so we can only assume as best as possible. The prices, however, I mentioned, they're coming from different studies. My main study I used for this was from the Fraunhofer. It was also mentioned in my slides.
Okay. When presenting on regulations, I think it was slide 9, you mentioned circular materials and markets. So David is asking how the asset owners can actually access the circular materials and markets like glass market.
Well, I'm not sure if as an asset owner, this is your go-to thing to get the materials back. It could be possible that you just, for example, have a mobile recycling plant coming to your big PV plant. I mean, I think only then it makes sense. And you recycle it yourself, maybe, and then sell off the material. Not sure how it works with the certifications, which is important. But I think that is just to a discussion point with the recycling facility itself. If this was a question.
Yep. Hopefully you answered the question. Let's see what other questions we have. David is asking, I think in your presentation you mentioned 50 euros per megawatt. Where does this assumption come from? Is there any study or official organization showing this number?
Yes, and it's not 50 euro, it's 50,000 euro per megawatt peak. And that is also to reply in the same time Ursula's message. It is for the whole PV plant to have the land plot as it was before. And from where is this numbers coming? As I said earlier, different studies. Main study was Fraunhofer, but also some other studies. The studies, however, are mentioned in the slides. I think on top right, there were the studies mentioned.
Okay. Another question for you, Andreas. I hope you're not tired of answering the questions. It's coming from Tim. You mentioned that glass cannot be reused in remanufacturing. Why is that?
It's lying on the tip of my tongue. There is a special material inside, which is used in the PV industry and is coming mostly from China. And there's a chemical material inside, and machineries or glass producing machineries in Europe cannot handle this material. Therefore, it has to go in another stream. There are markets who can use such glass, and I believe these were bottles or so, but you cannot reuse it yet for the PV itself. I can look it up again, what was the name of this, and can later let you know, Tim.
Okay, good, thank you. A question from Yevgenia. You mentioned average price for the commissioning of PV. Can you provide us with the average price for recycling BESS per ton or megawatt hour?
No, I can't. Sorry, I don't have the numbers yet.
Okay, no problem. Let's see what other questions do we have. Perhaps you would know the answer, Andreas. Are manufacturers looking at recyclable material usage during manufacture process?
I think not really yet, at least in the PV industry. And I know when I spoke, for example, to the guys from Solar Materials, that Chinese PV panel manufacturers are also very interested in recycling. And some are already having constructed recycling facilities next to the production facility. Maybe interesting for China. I'm not sure how to do it in the European Union because you're not allowed to export for recycling your PV panel. You have to do it inside the European Union. So it will be interesting to see how this whole market will develop in the future.
Indeed. I see that we have some questions about the recording of this session. So yes, this webinar is being recorded and will be shared, the recording link with the attendees and people who registered for this webinar. Then I see a question from Maslina. I'll take the liberty to answer that one. What is the suggested SAT testing requirement needed at installation site to check the quality before and after shipment? So in our experience, we typically recommend a focus set of on-site tests that verify product quality, both after shipment and after installation. And this includes EL testing, flash testing, visual inspections, insulation resistance checks, and for BESS, safety and BMS diagnostics. These tests usually give asset owners a final confirmation that, nothing was damaged in transit, and that the installation meets required performance and safety standards. Okay. Again, one question from Tim to you, Andreas. Considering these high recycling costs, which stakeholder can best stimulate design for recycling? The EPC, policy or manufacturing associations, or other groups? What do you think?
That's an interesting question, because actually by European law, the producer is in charge for recycling. So I didn't mention this during the talk, but there is this law by European Union that in the end, the producer, the manufacturer, has to pay for the recycling. It is same if you have, I don't know, a TV and you send it away or you give it to a recycling facility. It's not the recycling facility who's paying for it. It's actually the manufacturer of the TV. They're just having a contract with each other. So it is the manufacturer in the end, in his own interest, to have recycling as cheap as possible. But why I'm saying that you as an asset owner need to have a decommissioning bond in place, because in 25 years and 30 years, you don't know the situation with this manufacturer. Is it still there? And if it's in a foreign country, yeah, good luck to chase them, or if they're even not existing anymore, so it falls back to you. So you have to put this reserve in place. So it should be in the manufacturer's interest to make recycling as easy as possible, but it's also you have to provide for yourself to mitigate the risk with the decommissioning cost, and I would do it with a bond.
Okay. Andreas, a question from my side. If you had, let's say, an asset owner or investor in front of you today who is not willing to, include decommissioning in their financial model, decommissioning costs in their financial model, what would be your advice to them?
Well, my advice is then be ready to have higher finance costs, because lenders are going to pick this position up when they're going through the due diligence, and they don't see any planning for the decommissioning. Is for the lenders maybe also a risk which they compensate with a higher interest. And if your model is to sell the plant, and you do not have the decommissioning bond in place, you don't have a decommissioning plan in place, that might be also for the buyer a hurdle or a price negotiation to take the plant from you.
Okay, thank you. Yeah, go ahead.
I like just to say a last sentence. What my concern is also in general is or are stranded assets inside the European Union. If you look at an asset owner who doesn't care for the decommissioning, maybe the asset owner is outside of the European Union, and you have it like on a farmland, and after 25 years, the farmland, so it all ends up, and you have to decommission, and the asset owner just walks away, and you cannot do anything. And there's also no manufacturer anymore, but the manufacturer wouldn't take care of the dismantling just of the product itself. The concern is actually stranded assets. And the concern is like that in the end, DSO need to take care, or the landowner need to take care, or in the very last, what we see very often, the taxpayer has to take care. And I think everyone in industry, we should make sure that we're not ending up in this.
Okay, yeah, that's a good one. I'm conscious of time when I see we are 1 minute away from the end of this webinar, so I'll take just the last question coming from Gopinath. So Andreas mentioned BESS lifetime as 12 years, and currently few of the O&Ms where they are in contact are promising 20 years. So this is this an issue? So yes. Short answer from Sinovoltaics side is it could be an issue if O&M promises 20 years, while the real world BESS lifetimes are often closer to 10 and 12 years under typical cycling and thermal conditions. And we in the last webinar we had with Modo Energy, we spoke about BESS degradation, that BESS assets might be degrading faster than you than the manufacturer actually declares. So our advice would be you should validate lifetime claims through warranty wording, cycling limits, usable capacity curves, and independent technical assessments. I'm not sure if you want to add anything, Andreas.
Well, this is a promise, and that is probably also like in a best case simulation. I would always question this. And also, if you look back in the PV industry, what have been promised 20 years ago and where we are today, so I would take it with a grain of salt what they promise.
Okay, exactly. Well, thank you, Andreas, for joining me today for this webinar. We still have a couple of questions that we were not able to answer during the webinar, so we will be sending the answers in writing via email as a follow-up to this webinar. I think that one takeaway that I'm walking away from this webinar is that during the design phase, you can already make choices to make the decommissioning process easier and cheaper in the future. And regulation for decommissioning is already in place. And if you don't think about this process today, you expose yourself to a major risk. So thank you again, Andreas, for this insightful webinar today. I thank you, the audience, for such a big number of questions we received today. This is the last webinar of Sinovoltaics in 2025. So I look forward to welcoming you all again in January in 2026. Thank you.
Thank you, Radha. It was good to be here.
Thank you. Bye-bye.
Bye.
Visit Sinovoltaics.com to learn more.